Good morning, students. So, today we will be starting with our fifth chapter, which is based on 8051 IO code programming. Up till now, we have covered microcontroller basics, architecture of 8051, basic assembly language programming, and ALU instruction of 8051. Now we will be moving ahead with input-output port programming of 8051 microcontroller. So this is the outline of our session. We will be seeing introduction, then we will be seeing the description or understanding of port 0, port 1, port 2 and port 3. In 8051, we have 40 pin IC. The integrated circuit of 8051 consists of 4040 pins, from which 32 pins are allotted to 4 IO ports of 8051. Out of 4040 pins, 32 pins are allotted to 4 ports P0, P1, P2 and P3. Port 0, port 1, port 2 and port 3. And every port takes 8 pins. As you can see, out of 40 pins, 32 pins are allotted to the 4 IO ports. So 32 divided by 4. So every port has 8 pins. Now, these ports can be treated as input port as well as output port. How you can consider whether your port is treated as an input port or output port? Input port means, first of all, if you want to read any data from your peripheral, input output peripheral, then you have to treat your port as input port. Your microcontroller memory will read the data from IO peripheral and it will shift it to the memory of microcontroller. That is input port. Now how you will treat your port as an output port, and what is the role of output port? Output port means whatever data you are transmitting from the memory of controller to the input-output peripheral, that is known as output port. At that time, your IO port will be treated as output port, and at that time you are writing some data from memory to IO peripheral. So that is called output port. Output port means you are writing some data from memory of controller to IO device. And input port means you are reading data from IO device into the memory of controller. Both are reverse process. When 0 is written on port, your port will be treated as an output port, and whenever you are writing 1 or you are setting your port, at that time port will be treated as input port. This is the internal circuitry of port 0 of 8051 microcontroller. It consists of buffer. These are buffer gates which are used for read latch and read pin. This is D flip-flop. D flip-flop role here is it will simply transfer whatever input you are giving into output Q. This is inverter circuit. This is multiplexer based on the input coming from D flip-flop into mux. Your mux will process whether you are treating your port 0 as input or output. Transistor is going to be selected based on the mux output. So this is the internal circuitry of port 0 of 8051. It comprises of logic gates, multiplexer and flip-flop, as well as one transistor. Now port 0 is used for multi-purpose. Its SFR address is 8080 and it is a bit addressable port. SFR address means special function register address. See, in the starting of 8051 introduction, we have discussed that in every microcontroller, you are having different type of register set. First one is the general purpose register set, which we are using frequently whenever we are performing any operation like accumulator R0, R1, R2, R3 up to R7. All these registers are general purpose registers. We are using frequently whenever you are performing any task or you are executing any operation. While SFR means special function registers. Special function registers are those registers which you are using whenever you are performing any IO operation or external operation. If you are connecting any external device with your memory, at that time whatever the register space you are utilizing, that is allotted to SFR, special function register. So your all input output registers are included in special function register. So input output registers are also called special function registers. So the address allocated for port 0 is ATH. Now what is the role and function of this port 0? Port 0 is simple input output port. It can be used as input or output based on your requirement, and it is used for generating data and lower order address bus for external memory. And the lower order address bus includes AD0 to AD7 pins of microcontroller. Now whether you want to treat your 8 pins of port 0 as input or output depends on the connection you are giving. In order to use these pins of port 0 as input and output, you have to connect it with pull-up register. So if you are connecting these pins with VCC, that means you are setting your port. Setting your port means you are treating it as an input port. And if you are connecting this with ground, all pins you are connecting with ground, that means you are making your port reset. So your port will be treated as an output port. Port as input port. Whenever port 0 you are using as input port, you must set 1 to the corresponding 0 latch in order to cause both the output transistor to switch off and to float them in high impedance state. So read logic signal will be asserted by read pin signal. This is the facility provided by the input port of microcontroller. This is one facility of reading the port. Now next facility is making it treat as an output port or making it treat as an write logic level. Read contents of latch will be asserted by read latch signal. We have already seen the block diagram. In that, if you want to make your port as a read port, then you have to insert or you have to set your read latch and provide that output to the flip-flop. Now, whether you want to perform read operation or write operation, you have to set your port based on that. A read modify write operation is extra feature which is given to port 0 whenever you are performing read operation in latch. A read modify write signal is one wherein you are reading the data from port and you are modifying it and you want to write something else to the port. That is a read modify write signal. This feature has been extra given in port 0. Now port 0 simply treated as an output port. When port 0 is configured as an output port, the latch pins you are programming to 0. So it will cause the lower FET to turn on, NMOS will turn on whenever it will be given 0, and if 1 is written on latch pin of FET, it will turn off and it will be pin pulled as high by external pull up register. So all this working given to you in this slide is regarding this diagram. The working has been explained to you is regarding this diagram. So it depends on the operation you want to perform, whether you want to treat your port as an input or output. Based on that, you have to set the circuitry. Now next port is port 2. Port 1 we have already discussed. Port 0 also we have discussed. Both the diagrams are similar only. Slight modification is there in both the ports. So this is port 1. In port 1, one modification in the diagram is you can see here in port 0 there were two transistors connected back to back. Here only you have one transistor with pull-up register. This is pull-up register. So this is an extra feature in port 1 compared to port 0. Slight modifications are there in all the port diagrams. So you remember one diagram and then you remember the modifications in the other rest of the port diagrams. Now port 1 is a 1-bit simple IO port microcontroller. Its SFR address is 90H. The SFR address previously for port 0 was 80H, but for port 1 is 90H. And in port 1 we don't have any extra or alternate functioning like port 0. In port 0 extra functioning was read modify write option was there, but here in port 1 we don't have such facility. So this is regarding port 1 as simple input output port. If you want to treat your port 1 as input port, then you have to simply set 1 to the port 1, then it will be treated as an input port. Here the FET in the lower section will turn on. FET is your field effect transistor. In the diagram, this is your FET, the lower FET, and in the previous diagram, upper FET was also there, but here in port 1 we have only one lower FET, and on the upper side we have pull-up register. So here whenever you are giving 1 to the input port at that time, corresponding latch will be also given 1. It will be turning off the FET and the pin and input to pin will be set to logic high by the pull-up register. So at this time port 1 be treated as quasi bidirectional port. Quasi bidirectional port means whenever your output is high because of the input given high, that is known as bidirectional condition. Now, whenever you are treating your port as an output port, you have to program your port with reset mode, or you have to apply logic 0. Here the lower FET will turn on whenever you are applying logic 0. At that time, the internal pull-up register will be turned off and the input circuitry will have logic 0. In previous condition, logic set was high after applying 1, but here logic set is 0 after applying 0. And if you are writing 1 onto the latch, it will drive the input of the external circuitry which we have attached through pull-up register, and the lower FET will turn off. So this way you can make it first right, and after that you can set 1 to make it as a read port or as an input port. Now the next port is port 2. This we will be discussing in the next session. Up till now you revise the circuitry of port 0 and port 1. Today we have discussed the internal structure of your I/O ports of 8051 microcontroller. The two ports left are port 0 and port 2 and port 3, which we will be discussing in the upcoming next session. Thank you.